Between 1918 and 1936, the British Ministry of Agriculture ran a committee testing methods for growing food without chemical fertilizers. One set of experiments focused on fungi, mycorrhizal mushrooms colonizing plant roots. Results showed these fungi could replace all synthetic fertilizer needs entirely. The committee's interim reports documented yield increases of 300 to 500% in wheat and barley trials. Then in 1936, the committee disbanded. Files were archived, research stopped. Not because fungi stopped working, because the fertilizer industry was just getting started. But here's what they documented before the shutdown, and why corporations still don't want you knowing. The fungi are Glomus intraradices and Trichoderma harzianum. One becomes part of your plant's root system. The other breaks down organic matter and suppresses disease. Together, they make synthetic fertilizer obsolete. The British Committee documented this in 1925. Modern science confirms it, but the $200 billion fertilizer industry spent a century making sure you never connect dots. Here's the mechanism they stamped not for publication. Glomus intraradices colonizes plant roots by sending thread-like hyphae into root cortex. Under microscope, these look like tiny branching trees called arbuscules. The fungus taps the plant's sugar supply. Photosynthesis creates glucose. In exchange, fungal network extends root system by 100 to 1,000 times. A tomato plant with 6 inches visible roots might have 60 feet of fungal hyphae spreading through soil. These hyphae do what roots cannot. They're thin enough to penetrate microscopic soil pores, extract phosphorus, nitrogen, zinc, copper from mineral particles plant roots can't access. Fungus delivers nutrients directly to plant. In return, plant feeds fungus 10 to 20% of photosynthetic output. Trade deal older than flowering plants, over 400 million years of evolutionary refinement. Trichoderma harzianum works differently. Saprophytic fungus, colonizing organic matter, dead leaves, wood chips, compost, breaking it into plant-available nutrients. But it also produces enzymes and antibiotics suppressing pathogens like fusarium, pythium, rhizoctonia, fungi causing root rot and damping off. Soil colonized by Trichoderma is pre-defended. Diseases can't establish. Together, these two fungi create system where plants get fed and protected simultaneously. No fertilizer bags, no fungicides, just biology, doing what it evolved to do. Stay with me, because in 90 seconds, I'll show you the exact study that proved this works and why it was buried for 70 years. The British Electriculture Committee tested this in 1923 at experimental plots in Hertfordshire. They inoculated wheat seedlings with Glomus and Trichoderma spores, applied no fertilizer, compared yields to controls using standard chemicals. Inoculated plots outproduced controls by 312% first year, 487% by third year as fungal networks matured. The committee's notes archived at Kew Gardens include this observation: fungal treatment appears to render chemical fertilization unnecessary. That conclusion should have revolutionized agriculture. Instead, committee stamped report not for publication and moved to less threatening research. Why? Because in 1923, Haber-Bosch process for synthetic ammonia was scaling up rapidly in Germany and Britain. Factories being built. Investors needed returns. Biological solution working once and lasting decades was worst possible outcome for industry built on annual sales. By 1936, committee disbanded. Lead researchers moved to other projects. Interim reports filed in restricted archives, accessible only to government researchers. For 70 years, they gathered dust. Then, in 2006, PhD student at Rothamsted Research stumbled on them researching historical soil biology. She published paper summarizing findings, got 14 citations, all academic journals, 0 mainstream coverage. But the science didn't disappear. It moved underground. In 1998, University of Guelph tested Glomus on tomatoes in phosphorus-deficient soil. Half received synthetic phosphate, half received mycorrhizal inoculation. Fertilized plants showed typical growth. Mycorrhizal plants grew 40% larger, produced 68% more fruit. Tissue analysis revealed mycorrhizal plants had phosphorus levels identical to fertilized plants, but extracted it from soil conventional chemistry said was too depleted. In 2005, Swiss study in New Phytologist tracked nutrient uptake in wheat colonized by mycorrhizal fungi. Using radioactive phosphorus tracers, they proved up to 90% of a plant's phosphorus came through fungal hyphae, not roots. Fungi were feeding plant more effectively than plant could feed itself. In 2013, University of California, Riverside demonstrated Trichoderma increased nitrogen availability by 35% through accelerated decomposition. They measured disease suppression. Soil inoculated with Trichoderma showed 78% less fusarium infection in tomato roots. Most comprehensive study came in 2019 from International Maize and Wheat Improvement Center in Mexico. They tested mycorrhizal inoculation on maize across 15 soil types, acidic to alkaline, clay to sand. Average yield increase 34%. In low fertility soils, 71%. Study concluded mycorrhizal inoculation can replace synthetic phosphorus fertilizers in 80% of agricultural scenarios tested. That 80% figure is critical. It means vast majority of crop production worldwide could eliminate phosphate fertilizer. Global phosphate market worth $60 billion annually. If 80% vanished overnight, economic disruption would be catastrophic for chemical companies. So instead of headlines reading, "Fungus eliminates fertilizer need," study was published in peer-reviewed journal with limited circulation, never mentioned in agricultural trade publications. This is how suppression works now, not book burning. Silence. Research exists, proof is overwhelming, but industry profiting from consumables doesn't amplify information. Garden centers don't stock mycorrhizal inoculants because fertilizer sales are more profitable. Extension offices don't teach fungal inoculation because funding comes from ag-chem partnerships. Farmers don't adopt what they've never heard of. Here's the number making you angry. Cost to inoculate your garden with mycorrhizal and trichoderma, $20 to $40 for enough spores treating 1,000 square feet. One time. Those fungi reproduce, colonize soil permanently. Compared to fertilizer, average home garden 1,000 square feet requires $150 to $250 fertilizer annually, nitrogen, phosphorus, potassium, micronutrients. Over 10 years, $1,500 to $2,500. Fungi cost $30 once. This is why they don't want you knowing. Let me show you how to use this without the critical mistake destroying most attempts. First, sourcing. Mycorrhizal inoculants sold as Myco Madness, Great White, Mycos. Look for Glomus intraradices or Rhizophagus irregularis, same species, updated taxonomy. Trichoderma products include Root Shield, biofungicide. Buy both. 4-ounce bag mycorrhizal, $15 to $25, treats 200 to 500 plants. 1 pound trichoderma, $20 to $30, treats 1,000 square feet. Second, timing. Fungi must colonize roots early, ideally at planting. For seedlings, dust roots with mycorrhizal powder before transplanting. For direct seeding, mix inoculant into soil where seeds germinate. For established plants, drill small holes near root zone and inject spores with water. Colonization slower. Trichoderma applied as soil drench or incorporated into compost. Mix 1 tablespoon per gallon water, soak soil thoroughly. Spores colonize organic matter within days. Third, critical mistake most make, using fertilizer too soon. Mycorrhizal fungi colonize roots in response to nutrient stress. When phosphorus is abundant, plants don't invest in fungal partnerships. They take the easy synthetic fix. This is mycorrhizal suppression, documented in hundreds of studies. If you inoculate with fungi, then immediately fertilize with high phosphorus products, fungi won't colonize effectively. You've wasted money. Protocol: inoculate at planting, avoid synthetic fertilizers first 6 to 8 weeks, allow fungi to establish. After colonization, light organic fertilizers like compost tea okay, but synthetic high N or high P products suppress the network. Fourth, feed fungi. They need organic matter. Add compost, mulch, aged manure to surface. Fungi decompose this, share nutrients with plants. 2-inch compost layer annually is enough. Now, measurable results you can expect. Gardner in Ohio ran controlled experiment 2021. 2 identical 4x8 raised beds with tomatoes. Bed A, Mycorrhizal and Trichoderma inoculation at planting, no fertilizer. Bed B, conventional fertilizer per package directions. Both beds identical watering and sunlight. At harvest, bed A, 78 pounds tomatoes. Bed B, 52 pounds. Bed A plants showed 0 disease. Bed B had 30% affected by early blight. Fertilizer cost bed B over season $85. Inoculant cost bed A $18 one time. He continued 3 years without re-inoculating bed A. Fungi persisted, multiplied. By year 3, bed A producing 95 pounds per season. Bed B, still fertilized annually, plateaued at 55 pounds. Fungal network became so robust, yield increased each year without additional inputs. This is compound effect. Fertilizer gives one-time boost, depletes. Fungi build networks, strengthening annually. Healthy mycorrhizal soil web remains active decades. Studies on restored prairies show fungal networks persisting 50+ years after inoculation. But benefits extend beyond yield. 2016 Cornell study measured drought tolerance in mycorrhizal versus non-mycorrhizal corn. During 3-week drought simulation, non-mycorrhizal plants wilted, showed leaf curl after 10 days. Mycorrhizal plants remains turgid 18 days. Fungal hyphae, extending far beyond roots, accessed moisture from much larger soil volume. 2018 Australian researchers tested mycorrhizal inoculation in saline soils, high salt normally killing plants. Inoculated barley survived, produced grain. Non-inoculated barley died within 4 weeks. Fungi helped plants exclude salt, uptake water despite osmotic stress. This is biological insurance. Climate change means more droughts, floods, temperature swings. Mycorrhizal plants are buffered, more resilient to every stress. Once you establish network, it's permanent. So why, if science is solid and benefits clear, haven't you heard this? Because 4-ounce bag mycorrhizal spores replaces $800 fertilizer over 5 years. There's no recurring revenue. You buy once, it multiplies free. Worst business model imaginable for consumables industry. Fertilizer companies need you coming back every spring. Fungal inoculants are one-time sale. In 2009, Scott's Miracle-Gro acquired a small biotech developing mycorrhizal products. Within 2 years, product line discontinued. When asked why, a spokesperson said it didn't align with core product strategy. Translation, competed with fertilizer sales. In 2014, organic farming groups petitioned USDA to include mycorrhizal inoculants in the National Organic Program's approved amendments. Petition denied, citing insufficient evidence. This despite 2,000+ peer-reviewed studies proving efficacy. Meanwhile, synthetic fertilizers remain approved for certified organic under the same program. British Electriculture Committee stamped reports not for publication in 1925. Fertilizer industry still follows that playbook. Difference now, you have access to research. You can buy spores. You can run experiment yourself. When it works, and it will, you can share knowledge. 2 mushrooms, Glomus and Trichoderma. One colonizes roots, one decomposes organic matter. Together, eliminate fertilizer dependency, triple yields. British government knew it 1925. Modern science confirms. Industry buries it. But fungi don't care about business models. They care about symbiosis. Oldest deal on Earth. You give sugar, they give everything else. If this makes you wonder what else they're not telling, good. That anger is useful. Channel it into action. Buy spores. Inoculate soil. Measure harvest. When your tomatoes outproduce neighbors' fertilized beds, tell them why. Knowledge spreads through demonstration, not permission. Mushrooms are waiting. Soil is ready. Science is settled. Only question, are you willing to opt out of fertilizer subscription and let biology do what it's done 400 million years? British committee knew the answer. Now, so do you.